Hello everyone, my name is Travis McPhail and I'm the engineering lead for Maps and Immersive Experiences within Google Maps platform. I hope you're all having a great I.O. I'm here today to talk about how you can bring Google's advanced 3D geospatial imagery and generative AI capabilities to your applications. In this session, you will learn how to quickly create and customize 3D experiences in the Maps JavaScript API and how to build innovative AI-powered applications using our places data. Let's get started. Last year at I.O., we walked you through two major components of photorealistic 3D experiences and launched two products to support these components. The first component was a photorealistic textured 3D mesh, which is the foundation for 3D experiences. To give you access to this mesh, we launched photorealistic 3D tiles through the Maps Tiles API. Photorealistic 3D tiles enable developers to create powerful visual experiences using a renderer of your choice. The second component was a pre-built 3D visualization experience, which we launched through the Aerial View API. Aerial View gives you access to pre-rendered 3D cinematic videos to support glassable use cases or immersive experiences on devices with low-power graphics hardware. Now, if you remember, I conveniently left out the third component, the software that brings interactive 3D experiences to life, a Google-powered renderer. Well, today, I'm thrilled to share that we are launching the third component for JavaScript Maps developers, the Mesh Renderer. Starting today, you can access Google's photorealistic 3D maps through the same Maps JavaScript API you already use. For the first time, you can take advantage of Google's proven rendering technology to deliver rich 3D maps at the speed your users expect. And the best part is that you can get started with just one single line of code. Let me now hand over to our lead engineer on this project, Aleh, to walk you through a demo.
Thanks, Travis. Hi everyone, I'm Aleh, software engineer on the Google Maps platform team. When I talk to Maps developers, being able to access an Earth-like real-world experience has been one of their top feature requests. That's why I am so excited to announce the experimental release of photorealistic 3D maps in the Maps JavaScript API. Starting today, you get access to Google's rendering capabilities and can quickly visualize over 2,500 cities in over 50 countries at city-to-globe scale. Now, let's walk through how to get started and look at the key components that you can experiment with today. Let's start in the console. If you already use Maps JavaScript API, you can access 3D maps through the same service, no extra steps needed. If you are new to Google Maps platform, just enable the Maps JavaScript API in the Google Cloud Console and you are ready to start using 3D maps. Now, getting access to all of the functionality starts with just one line of code. First, we need to load the Maps JavaScript API on the page. The simplest way to do that is by using a script tag that includes your API key. You'll also need to include the Maps 3D library to make 3D maps available in your app. Like other features in the JS API, 3D map was designed as a web component, a custom and reusable HTML element, which can be created either through HTML or JavaScript. The next step is to add a Map3D element to the page using the GMP Map 3D tag. All you need to do is to add it to the place you wish the 3D map to appear. Here you can see the 3D map centered on the Amalfi Coast in Italy. In order to create this view, we need to set a few attributes on the Map 3D element. First, we set the center point to the center of the screen, including the height above the ground in meters. Next, we set the distance away from the point we want to look at, using the range value, again in meters. Last, we set the angle from the ground we want to view from, using the tilt value. With all those attributes set up, we now have a working 3D map on the page. We can interact with it like a normal 2D map, including panning and zooming around the area. And we see all of the rich places information that's automatically integrated into the 3D base map. You can use JavaScript to automatically control the view, move to new locations, or modify the look of the globe. Let's have a look at how to do some of that now. So we are looking at the Amalfi Coast. Pretty amazing, right? But let's say we want to explore somewhere totally different. We can do that with just a few simple lines of code. First, we need to find the Maps 3D element and update its properties to change where it's pointed at. We can call this function from any button added to the page. By the way, there are other ways to adjust Maps view, like setting the role. We won't dive into that today, but know that you have lots of options to control your 3D map. Once we have the full page, we'll head to Toronto with a single click. Moving around the globe in an instant really allows you to create new, rich, immersive experiences that were not possible in the Maps JavaScript API before. While it's fun to explore the globe, you might also want to create focus experiences for your users. Camera limits and map boundaries can be defined when creating the Maps 3D element. There you can set the maximum or minimum values for tilt or altitude, so users navigate within that range. You can also set the bounds of the map through code to keep your users engaged in a specific area. Now we can see how to manipulate the location of the map with JavaScript. Before we add features to the map, we might want to remove some of the base map elements, like borders, roads, places, and labels. This lets your users just focus on the 3D features and edit elements without distraction. To do this, we added default labels disabled HTML attribute to the tag. We can also have a small JavaScript code to toggle this attribute on or off when required. Here we can see it added to the Maps 3D element, centered in Toronto, and how that looks after loading the map. Now that we are happy with this view, let's go ahead and start drawing on top of the map. Adding lines and shape to the map can help highlight specific areas of interest or convey information to your users. Let's start by highlighting an area in Toronto using a polygon. We first need to add a polygon to the Maps 3D element and set the style. We can style both the area and the line around it in different colors, as well as make both of them opaque in order to see the underlying real-world features in the view. Note that apart from the styling features, we also have the Draw Secluded Segments attribute, which can be used to show whether to view parts of an object that might be behind other features. Next, we add coordinates and define the altitude mode for this polygon, so that it can be positioned properly. Looks really cool, right? Now, let's say we want to highlight a building instead, top to bottom, given its altitude. We can do that with a few additional modifications. First, we need to make sure the polygon has the extruded attribute associated with it, which then tells the view to use the altitude values of this feature. We then change the altitude mode on the polygon to either absolute or relative to mesh, depending upon the nature of the height values. In this case, the values are above the ground to cover the landmark that we are highlighting. And here's our final polygon around the CN Tower. In dense areas like cities, adding a third dimension is an easy way to highlight key elements that might otherwise blend into the 3D landscape. This approach can also be used for polylines. Here we can see a route across Toronto obtained from the Routes API, which is rendered onto the 3D map using the polyline element. Once again, we specify the polyline points to give it shape and then the height of each point. There is a great deal of flexibility within both the polygon and polyline elements, so you can easily customize the look and feel to match your style preferences. So you can imagine where you might take this next. Following the route, this simple polyline quickly transforms into a dynamic, data-driven experience by visualizing real-time traffic information and guiding viewers through the city. I hope you've already started imagining ways to bring your own 3D experiences to life. We are excited to share these capabilities with you today, but it's your input and creativity that will really take things to the next level. I look forward to seeing all the amazing 3D experiences you built with the Maps JavaScript API. That's it from me. Back to you, Travis.
Thank you, Aleh. With this launch, we are offering you even more choice to pick a 3D solution that best fits your needs. Whether you want to use your own renderer or leave the rendering to us, we have you covered. And we have a fantastic demo along with a great set of docs and sample codes to help you get started. Now let's switch gears to one of our most beloved products, Places API. For the first time ever, we are starting to bring the advanced reasoning and generation capabilities from the Gemini model to features of our Places API. Now you can build AI-powered applications that make it easier for users to find the exact places they're looking for without having to comb through countless reviews, photos, and place attributes. I'm excited to announce that these generative AI capabilities for Places API are now available to all developers worldwide as an experimental release. They are initially available for Places data in the US and will expand to other countries over time. The AI-powered capabilities for Places API enable you to provide rich, generative summaries that highlight the most helpful information about a place or area, utilizing more insightful place data and contributions from Google Maps users than the Places API has ever done before. This saves your users time and effort to search for and select where they want to go, and it also saves you development time and resources. Now, you can help your users find just what they are looking for and do it much more quickly through comprehensive and insightful generative summaries. Whether it's finding the best taqueria in the Gaslamp district of San Diego or the best Italian restaurant in the East Village neighborhood of New York, you can now make it super easy for your users to find the ideal places to visit. You can also help your users make decisions about what boutique hotel to stay at in Chicago, based on AI-powered summaries of which restaurants, nightlife, and attractions are within walking distance of the hotel, saving them time. These capabilities enable use cases across many verticals, such as travel, real estate, auto, retail, social media, and more. Let's take a look at a demo showcasing how these capabilities can be used by automakers. Imagine a driver is in one of your vehicles, driving from San Francisco to South Lake Tahoe, and wants to plan a detour to get dinner. This is a situation that normally requires an involved search and selection process to find a restaurant that is convenient to their route, has the type of cuisine they're in the mood to eat, and has good reviews. But they're driving and need to keep their attention on the road. This is where the new Gemini model capabilities for our Places API really shine. Using the driver search query, the navigation system can find the ideal location based on the type of place the driver is looking for. We return all the data you're used to getting in a Places search, things like ratings, reviews, photos, and hours of operation. But now we also return a summary of that same data, created by the Gemini model, which is more useful for making quick decisions while driving. Let's see how it works. Find me a Mexican restaurant.
I found Ken's Taqueria, Danville. Here's a summary of this place. Casual Mexican eatery serving tacos, burritos, and other traditional fare, plus margaritas.
This is an example of an overview place summary, which provides a one-line description of the place. These summaries are brief and to the point, helping the driver get a quick sense of what a place is like without needing to comb through a bunch of place attributes. We generate them for a variety of place types, with much higher coverage and data freshness than human-generated summaries in Places API. For restaurants that have a good base of user-generated content, such as reviews and photos, you can now provide AI-powered descriptive place summaries. These surface the most helpful insights about a restaurant, such as popular dishes, flavors, value, and service quality. Descriptive place summaries can be up to 650 characters and provide our richest and most helpful places information ever.
Located in the Crossroads Shopping Center, this branch of a Mexican restaurant chain offers classic dishes for dine-in, takeout, and delivery. The menu features Mexican staples like burritos, tacos, and margaritas. People mention the happy hour, the large portions, and the outdoor seating. The venue has a bar, and some say the service is fast. Customers typically spend $10 to $20.
As you can see, these generative summaries help you enable your drivers to quickly understand what a place is like and how it's unique from other nearby options, without having to pull over to comb through a large number of reviews and photos. Finally, let's imagine the driver is looking for the ideal charging station to charge their EV. With the new Places API, you can offer data for EV charging stations. This means your drivers can optimize their driving based on charging station information, like which stations are available, the type of connector a charging station accommodates, and max charging speed at each station. And now, we are introducing area summaries, which are helpful AI-powered descriptions of the area surrounding a place. This can be especially useful when you're looking for specific recommendations of what shopping, restaurant, and coffee shops are available within a short walking distance. For example, the driver and their passengers may want to eat something while they charge, so they'll need to know what restaurant options are available within a short walk. Our new area summaries enable you to help them decide just that. Let's take a look.
Within a 1 to 3 minute walk, there are several dining and grocery options, including In-N-Out Burger, Kabila Restaurant, Panda Express, and Sprouts Farmers Market. For coffee and other beverages, consider Starbucks or Peet's Coffee.
And last but not least, contextual search results provide information in text search results such as specific photos and reviews that give context on why certain search results were picked. This enables you to give your users more confidence in your place search results. For example, if a driver searches for a dog-friendly restaurant, we can provide place photos with the search results that show relevant photos of dogs at the restaurant. You can try the new Gemini model capabilities in Places API at no cost during the experimental phase. To get started, visit the documentation for the new Places API. Thanks again for joining Aleh and me today. And do not forget to check out our documentation and developer site to keep up to date on available tutorials, news, videos, and more. And as always, we need your bug reports, your feature requests, and your feedback to help us test and improve upon our offering. So please submit them through the public issue tracker listed here. Again, I'm Travis McPhail, and we hope you'll give these new Google Maps platform products a try. We can't wait to see what you build. Have a great I/O, everyone.